Depends on if they're still over there or not. I had
There's
one.
not. Oh,
There was one over there. You
One
can
minus
look.
one.
I think that was the one I grabbed, because,
I did 1 minus.
she has a PDF though.
Ooh,
oh, okay.
typical Grant.
I will be here for so I won't miss.
Oh,
this
okay.
Friday.
Just Friday?
Yeah.
Okay. Are you on any of my rosters for Friday? I don't know. It's Friday. Okay. So on this one, we are wanting the integral. I would rewrite this as 5z plus 4 to the negative 8. So the antiderivative, add 1 to the power. So negative 8 plus 1 is negative 7. That means you need the reciprocal in front. So we need a negative 1/7 in front. Think about your derivative. Exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside. What's the derivative of the inside? 5. So if I am going to cancel that, I have to multiply by 1/5. So that gives me a negative 1/35 times 5z plus 4 to the negative 7. And what else do I need?
C.
Plus c. Alright, and you can check it by doing the derivative. Number 5. Integral from negative 2 to negative 1. 1 over x squared, that's x to the negative 2. So if you add 1 to the power, that's negative 1, so that means you need a negative 1 in front to cancel it. So that if you do the derivative, the negative 1's drop, x to the negative 2. We're evaluating from negative 1 to negative 2. So, this is a negative. X to the negative 1 is like saying 1 over that. Okay, so that's a negative 1. Minus, if I do negative 2, we have negative 1 over negative 2. So we get 1 minus 1/2 or 1/2. Does that make sense? I could have written that with fewer negatives, but I was trying to show you where everything was coming from. So problem 6. Roll from 1 to 3. 10 over 2x plus 3 squared. So that's like 10 times 2x plus 3 to the negative 2. So the antiderivative, the 10 is just going to come along. You add 1 to the power, so it's a negative 1. So what do we have to have in front to cancel that negative? A negative. Think about chain rule. So you would bring down the negative 1, that gives us a 10, 2x plus 1 to the negative 2. But derivative of the inside is 2. So to cancel that, I have to multiply by 1/2. So we get a negative 5 times 2x plus 3 to the negative 1. I'm evaluating from 1 to 3. So you're welcome to just pull the negative 5 out if you want. If you put in a 3, 6 plus 3 is 9 to the negative 1, so 1/9. Minus, if you put in a 1, 2 plus 3 is 5 to the negative 1, so 1/5. And let's see, you could distribute negative 5/9 plus 1, which gives you 4. Are those okay? So were we missing like calculation errors or antiderivative errors on these? Okay. So for an absolute value, we have to think about the pieces. The breaking point is when the inside is equal to 0. So that's when x is 3. So we're going to integrate from negative 1 to 3, and then from 3 to 5. Okay, if you are between negative 1 and 3, so give me a number between them, like 0. If you plug in 0, 3 minus 0 is 3. Does the absolute value change it? No, so it's just staying the same. If you put in a number between 3 and 5, like a 4, 3 minus 4 is negative, so we have to do the opposite, so -3 plus x. Because the absolute value would change it to make it a positive. So antiderivative, this would be 3x minus, if you add 1 to the power, that's x squared, so it gets a 1/2. -1 to 3. This would be -3x plus 1/2 x squared. And 3 to 5. So if I plug in my 3. 3 times 3 is 9, minus 9/2. Minus, if you put in -1, you get -3 minus 1/2. Look here, if you put in a 5, -15 plus 25 over 2. Minus, if you put in a 3, -9 plus 9/2. And so this is when you now start working everything out. I don't know how much work you guys want me to show here, so this would be like minus 7/2, minus -7/2, so plus 7/2. This would be like -30 over 2 plus 25 over 2. So -5 over 2 minus a negative, so plus 9 over 2. So 10 over. That's okay? Number 8, let's start by FOILing on the top. So if you do that, you get 4, sorry, you get 4 plus the square root of x. Can I just go ahead and square those? So it would be 16 plus 8 radical x, or I'm going to write it as 8x to the 1/2. Plus the square root of x times the square root of x is just x. Okay, we can't do a quotient, so we have to go ahead and divide these. So 16 divided by 2x to the 1/2 would be 8x to the -1/2.
I'm doing your integral 1 to 1. I'm doing your integral 1 to 1.
1 to 4?
Not in your second one.
Oh. 4. When I divide those, 8 divided by 2 is 4, the x's drop. X over x to the 1/2. So those you subtract and get x to the 1/2. The 2 is on the bottom, so that's like 1/2. X to the 1/2. Is everybody okay with that simplifying? So antiderivatives, if we add 1 to the power, so -1/2 plus 1 is positive 1/2. That means we have to take 8 times the reciprocal, so 8 times 2 would be a 16. Antiderivative of 4 would be 4x. Here 1/2 plus 1 is 3/2. Reciprocal is 2/3 times my 1/2 is 1/3. So now if I plug in a 4, it's like 16 square root of 4 plus 4 times 4 is 1/3 times the square root of 4 cubed minus, if I put in a 1, square root of 4 is 2 times 16 is 32 plus 16. Square root of 4 is 2, cubed is 8, so 8/3. Minus 20 and minus 1/3. So we get minus 20 is 28.
Did you know the answer or just did it?
I mean, I do have the answer, but I was working through. I added those, so 28, and then convert it, take it times 3 if you're counting denominator, and then
So what
plus
I
the
said.
seven thirds.
Totally in my head, yeah.
That's why I said, man, she did that crazy fast.
Are we okay on those? Problem 10.
Put it into the mix number.
So the acceleration is 10t minus 6. I know position at time 0 is 5. Velocity at time 0 is 0. I want to find position. So the antiderivative of acceleration is what?
Position, velocity.
So if you add 1 to the power is t squared, so 10 times a half is 5. Antiderivative of 6 would be a 6t, and we know we have to have a plus c. But I know the beginning velocity is 0. So if I plug in 0 for all of my t's, we get 0, so that constant is 0. That means my actual velocity function is just 5t squared minus 6t. I want position. So if we do the antiderivative of velocity, we get position. So add 1 to the power, that's cubed. So multiply by a third, so 5 thirds. Add 1 to the power, that's squared, so 6 times a half is 3. Plus a new constant. I'm going to pick a different letter, just to eliminate confusion. And now I know when my time is 0, this has to equal 5. So that means my k is 5. So my actual position, 5 thirds t cubed minus 3t squared plus 5. So 2 antiderivatives, find your constant both times. Is that okay? So f of x is 9 minus 4x. I want to find the area on the interval 1 to 2. And I tell you, by finding the sum from 1 to n of f of x sub I, change in x, and then taking the limit, as n goes to infinity. So I'm telling you, you have to use this method. To do that, we need to know what x sub I and change in x are. So change in x is ending minus beginning divided by n, so we get 1 over n. X sub I is your first point plus the change in n times I. Are we okay with that? No, that's the limit. As n goes to infinity. Sum from 1 to n. F of x sub I says you go to your function and you replace x with x sub I. So 9 minus 4 times 1 plus 1 over n. Times the change in x, which is 1 over n. So if we work this out, that gives me 9 minus 4 over n I times my 1 over n. Nine minus 4 is 5 times 1 over n would be 5 over n. Minus 4 over n I times 1 over n is 4 over n squared I. Is everybody with me to this point? Now I'm going to do the sum. When I do that, my summation goes away. We are adding up the i's. When I look, 5 over n doesn't have an I. So what happens when you add that up?
Multiply by n.
Minus 4 over n squared times the I formula is
N times n plus 1.
so we want to simplify as much as we can. So this gives using 5. I could drop out one of these ends. 4 divided by 2 is 2. Which one is n? Because it's negative 5 minus 2n over n, which is b2, because those n's cancel. Minus 2 over n. If n goes to infinity, a number over infinity turns into 0, so we get 5 minus 2 minus 0. 3. Is this helping? Hopefully in combination with yesterday, it makes a difference. Problem 16. We want the over and under approximation. F of x is 9 minus x squared. My interval is 1 to 3. And n is 3. So, we have over and under. If you don't know which is which, you could always just wait until you calculate them, and the bigger one is the over. What we know is our change in x, 3 minus 1 over, what's my n? 3. My change in x is 2/3. Okay, so on both of these, we will be multiplying by 2/3 because we're adding up the rectangles, length times width. And I'm adding 3 things in here. Right, one of them I have to start with 1. The next one you'll start with what? So 1, if you add 2/3, the decimal isn't perfect, it's 1.6 repeating, or 1 is like 3 over 3 plus 2 over 3 is 5/3, if you did that. So, because I am subtracting, my over is going to be the one where I subtract the least, so it's going to be the one where I start with my 1. And then you add your change in x. So 1 plus 2/3 is 5/3. 5/3 plus 2/3 is 7/3. Alright, and at this point, it is just a matter of plugging it in, which on the test, you won't be able to, so what I'll probably ask you to do is set it up, but not make you evaluate it unless it was just really nice numbers. And so I get 11.85. 185, so 19.852. For the under, you take off the first one. So we're going to start with the 5/3. Then your 7/3. Next one, you add your 2/3, so that's 9/3 or 3. So we ended our other endpoint. And if you do that, you get 6.518. Is that okay? We want to evaluate the interval from 0 to 5. 2x cubed minus 4x squared plus x plus 1 dx by doing the limit. So, we come up here. We need need to find out what our change in x is. So ending minus beginning divided by n, so it's 5 over n. We need x sub I, which is our starting point, plus the change in x times I. So 5 over n I. The limit and the sum, replace that interval. F of x sub I. Here's my function. I'm just replacing my x's with 5 over n I. So 2 5 over n I cubed minus 4 times 5 over n I squared plus 5 over n I plus 1. And my change in x replaces my dx, and my change in x was 5 over n. So now we start simplifying. So 5 cubed is 125 times 2 is 250 over n cubed I cubed. 25 times 4 is 100 over n squared I squared. 5 over n I plus 1. I'll have to multiply my 5 over n. Alright, so 250 times 5, 1,250, n cubed times n is n to the 4th, I cubed. 100 times 5 is 500, n squared times n is n cubed, I squared. 25 over n squared I. That's 5 over n. Is everyone with me to this point? Now I'm going to do my summation rule. So my sum goes away. 1,250 over n to the 4th. Then the I cubed formula is n squared plus 1 squared over 4. Minus 500 over n cubed times my I squared formula. N plus 1, 2n plus 1 over 6. Plus 25 over n squared. My I formula, n plus 1 over 2. Plus 5 over n, that's a constant, so it gets times n. Alright, now, lots of multiplying. How many shortcuts are you going to allow me to take?
All of them. You can rather answer.
So 1250 divided by 4, what does that reduce to?
625 over 2.
Okay. I'm going to go ahead and drop off 2 of the n's, so that's an n squared. And n plus 1 squared would be n squared plus 2n plus 1. Okay, I'm going to simplify as much as I can. I'll do it in 2 steps. 500 over 6, what's that reduce to?
30. No, that's not right. I don't know. 500 over 6. That's
250
Probably
over
less than
3.
250 over 3.
And I'm going to reduce one of my n's. And I'll FOIL those. 2n squared plus 3n plus 1. And drop off one of these n's, so I have 25, n plus 1 for n. And 5. Okay, so 625 n squared over 2n squared, give me 625 over 2. Plus 625 times 2n over 2n squared. 625. So, this turned into those three terms. This one is minus, so I'm going to distribute my negative. Negative 250 times 2 would be negative 500 n squared over 3. What'd I do? Oh, that's a cube. I made it a square right there. There we go. So that would be 500 over 3n. Or, sorry, 500 over 3. Minus, those would cancel in 250 over n. Minus 250 over 3n squared. So this turned into these terms. Okay, then 25n over n would be 25. 25 over n plus
Is
5.
that not 25 over 2?
Thank you. Okay,
Where'd that two come from?
I dropped it when I went from one step to the next. So now all of your n's on the bottom go to infinity. So anything with an n on the bottom cancels. And we are short on time, so I'm just going to tell you this is 490 over 3.
Oh my gosh, really good doing that.
Okay.
I don't know if I got this next one right or wrong because all my stuff was in fractions. And you gave me decimal.
On 19?
Yeah.
Okay,
Oh,
so
I definitely got
19, I'm going to set up. Let's see, we're kind of running short on time. So my change in x, we're going from 0 to 5. So 5 minus 0 over 4 is 5 over 4. Or if you prefer fractions, you could say 1.25. So for the left hand, all of these have a width of 5/4. So for all three, we're starting with 5/4 times something. And we are doing 4 pieces. So we have 4 things that we add together on all of them. The only difference is where we start. So my interval began at 0. It ended at 5/4, or 1.25. So the left-hand sum would start with the left-hand point. So the first x I plug in will be 0. So it's 0 cubed minus 1. And then you're adding 1.25, so 0 plus 1.25, so 1.25 cubed minus 1. 2.5 cubed minus 1. 3.75 cubed minus 1. You're welcome to do those in fraction form. When you add that, you should get 82.891. I'm just going to kind of tell you how to set them up and how to get the answer there. On the right, you start with your right midpoint. So that means the first x I plug in is the 1.25. Then you add your change in x. So 2.5 cubed minus 1. 3.75 cubed minus 1. And plus 1.25, 5 cubed minus 1. You add those, you get 239.14. Midpoint, you have to start in the middle. So if you add them up and divide by 2, that's 0.625 or 5/8. So the first x I plug in is 0.625. But you're still adding your change in x each time. So the next would be 1.875. Add your change in x, so 3.125. Add your change in x, so 4.375. I'm going to get 146.36. Alright, We understand the setup on those?
Yeah. I just dropped a term on the left.
I did it right, my fractions were weird, but I got it.
Gotcha. Okay, problem 20. We are building a box whose base length is 6 times the width and it will enclose 20 cubic inches. So, picture is probably helpful here. On the base, the bottom of the box, if one side is X, the other one is 6 times that. So I know some people use L's or W's, whatever, doesn't matter. But on the base, one side would be a variable and the other is 6 times that. And I don't know my hat, so you could call it H or Y. Either way. I know the volume is 20. Volume is from multiplying all three. So if you take 6x times y, you get 20. We always try to solve for one of the variables. So that means y is 20 over 6x squared, or that reduces to 10 over 3x squared. We are trying to minimize the cost. So now we have to come up with a cost equation. Okay, it tells me how much I have to pay for each side. So the sides of the box cost $3. So if I think about this area is XY and this one is XY. So we have 2XY, right? And how much do we pay for those? 3. Alright, now I'm going to add my left and right. So these are still $3 because they're sides. This would be 6XY plus 6XY, so that would be 12XY. Okay, top and bottom cost me $15. So the area of the top is x times 6x, so 6x squared. And 6x squared would be
12x.
So this is 6x, but instead of y, I'm going to do my 10 over 3x squared. This one is 36x instead of y, 10 over 3x squared, because we can only have one variable. 15 times 12 is, so my cost. This turns into 60 over 3, so 20 over x plus 120 over x plus 180x squared. So this will be 140 over x, or I'm going to write it as 140x to the negative 4. Because if I want to maximize or minimize, what do we have to do now? Derivative. So all that work was to get a simplified cost function. Now we do the derivative. So negative 140x to the negative 2 plus 360x, and we always do the derivative and set it equal to?
Yeah.
Okay. So if I add over my 140x to the negative 2, that's like 140 over x squared. Divide the 360, so 140 over 360, 37 over 18.
Dang.
And then cube root, it does not come out nice. Approximately 0.73. And so then you had to tell me the dimensions. Okay, we know one side was x, the other side is 6x. So if you do 6 times 0.73, that's your 4.38. And the last side you can plug it in here, 10 over 3x squared.
6.26.
So, on these, you have to get everything in terms of one variable, then do the derivative of the thing you're trying to maximize or minimize. I know I went through that kind of fast. Are we okay?
Oh, yeah.
If we need to go over that again, come see me tomorrow or after school or something, and I'll be happy to slow it down. 21. We are trying to find the price to maximize revenue. So that means we have to get a revenue equation. We know that if we sell the tickets for $50, so 50 would be the price, we can sell 1,200. So the number of tickets is 1,200. Price has to be the Y. Okay. The dollar amount is always our Y on these. If she raises the price $5, so if it's 55, 50 less people attend. So 1,150. So here you have to get your equation. Can I just tell you, if you work this out, y2 minus y1 over x2 minus x1, you should get negative 110. Plug into and I'm kind of breezing through, but if you solve that, your B, come in, is 170. So now we have our price.
I'll be gone for the rest of the week. Is there any, worksheets I need?
Do you have the notes handout for tomorrow already? Okay. So you'll need that, and then homework will be on Math Excel the next 2 days, and Friday will be handout on Classroom. So just watch the videos, and it's all from that notes handout we'll be working on for the next few days. You're welcome. We want to maximize revenue. So how do we get revenue?
Multiply
T
by
times
x.
cube x, x and cube x.
So revenue, 1/10 x squared plus 170x. If you want to maximize or minimize, you do. And set it equal to 0. And if you do that, okay, but I wanted the price, so I have to take my 850 and plug it into my price formula. That's where good labeling is really important.
You okay, Grant?
I divide by 5. Oh, goodness gracious.
And so if you plug that in, you should get $85.
You did it right. You just did
Well,
it
yeah,
wrong.
what was
You
the
did it
price
right, you
once
just did it
divide by
silly.
5? $34.
That's gonna make my
Yeah,
next
that's
Really?
definitely.
Well, I saw 85, and I was like, that's a
That
lot
might-
higher
that's
than
a modest
50.
Yeah.
Is that one okay?
Yeah.
Alright, let's try to run through a couple L'Hopitals real quick.
I think it's just that I don't remember what the optimization's not the word I want.
Indeterminate.
That one.
Okay, so 1 over a smaller and smaller number is going to infinity. 1 over a smaller number is infinity minus infinity. We can't do that. So our strategy with fractions was common denominator. So we're going to take the first one times natural log x. Can I go ahead and put these together?
Yes,
Yep.
minus x.
Okay, so that's what we get there. You can certainly distribute this negative. So then if you do that, natural log of 1 is 0, minus 1 plus 1, so we get 0 over 0, which tells me we can do okay, derivative of natural log is 1 over x, minus derivative of x would be 1, derivative of 1 is 0, so that's gone. Down here, product rule, derivative of the first times the second plus the first natural log x. Derivative of the second is 1. So I have 1 over x minus 1 over 1 minus 1 over x plus natural log x. Okay, kind of ugly. What I would probably do here is multiply by x on top and bottom so we don't have fractions within fractions. Do you need a pencil, Sam?
No, all of them are becoming like halfway broken, so like I need a pen. One needs lead, one needs an eraser, one is broken. So I'm like combining some Frankenstein.
You can tell the end of the school year is near. So it's still 0 over 0, so we do L'Hopital's a second time. Derivative of 1 minus x is negative 1 over 1 plus, for the x natural log x, you do practical. Derivative of the first times the second plus the first derivative of the second. At this point, we have negative 1 over 1 plus the natural log of 1 is 0 plus 1. And that's negative 1/2.
I just quit too early because I just didn't.
Alright. Is that one?
Oh, yeah. You got the last one.
Okay.
So fast.
We can do this.
We have 4 minutes. We got this.
Whew.
Oh,
I feel like I have been speed talking
This is
here.
like a workout for you.
It's like an auction, like an
No,
auctioneer.
this is like not even a workout. It is
Okay, bro.
This is actually meant
for
to
her.
For her?
Yes,
This is fun.
But I'm saying like she did like 20 of these.
Okay, so at this point,
This
if
is
I
for
plug in
daily.
0.
She said I'm not doing the whole
One
study
to the
guide.
infinity.
It's like 85% of the study guide.
So 1 to the infinity, that means we have to add
A natural law.
natural log. If you're going to add a natural log, your answer is
Not gonna be e to something.
okay. The whole reason we add natural log is because exponents come down in front. So we have a limit as x approaches 0. If I multiply by 1 over x, that's just really having an x on the bottom. Okay, so now I get the natural log of 1, which is 0, over 0, which tells me
Look down.
derivative of a natural log is 1 over the argument. Chain rule though,
That's
derivative of the
two.
inside is 2.
Over 1.
2 over 2x plus 1.
There's
And the
actually
zeros, we
What's
get
this?
2 over 1 or 2.
2. And then t squared. Oh my god.
Oh my
Oh my
gosh.
gosh. Oh my god. I did it.
Go, go,